Why choose a Sleep Number smart bed?
Can I make my side softer?
Can I make my side firmer? Can we sleep cooler?
Sleep Number does that. Cools up to 8 times faster and lets you choose your ideal comfort on either side. Your Sleep Number setting. And now, save 50% on the new Sleep Number limited edition smart bed. Limited time. Exclusively at a Sleep Number store near you. Learn more at sleepnumber.com.
This is SpaceTime, Series 28, Episode 22, for broadcast on the 19th of February 2025. Coming up on SpaceTime, new Van Allen radiation belts discovered around the Earth. Could an alien ocean hide signs of alien life? And the largest black hole radio jet ever seen in the early universe. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The largest solar storm in more than 2 decades hit planet Earth back in May 2024. For several days, wave after wave of high-energy charged particles from the Sun slammed into our planet. Brilliant auroral activity engulfed the skies, and navigation and communication systems were temporarily disrupted. With the help of a serendipitously resurrected small NASA satellite, scientists discovered that this storm also created 2 new temporary radiation belts of intense energetic particles encircling the Earth. The findings are important, helping scientists better understand how future solar storms could impact our technology. The new belts form between 2 others that permanently surround the Earth, called the Van Allen radiation belts. Shaped like concentric rings above the Earth's equator, these permanent belts are composed of a mix of high-energy electrons and protons that are trapped in place by the Earth's magnetic field. The high-energy electrons and protons that have found their way into Earth's inner magnetic environment in these belts can damage spacecraft and affect the health of astronauts who pass through them, so understanding their dynamics is key to safe spaceflight. The discovery of the 2 new belts, reported in the journal Geophysical Research Space Physics, was achieved by NASA's Colorado Inner Radiation Belt Experiment spacecraft. It's especially important for protecting satellites launched into geostationary orbits, since they need to travel through the Van Allen radiation belt several times before reaching their final orbital position. Temporary radiation belts have been detected in the aftermath of large solar storms before. But while previous belts have been composed mostly of electrons, the innermost of the 2 new belts also includes energetic protons. This unique composition is likely due to the extreme strength and composition of the May solar storm. The study's lead author Jinlin Li from the University of Colorado Boulder says the new belts seem to have lasted much longer than previous belts did. Whereas previous temporary belts lasted around 4 weeks, the new belt, composed primarily of electrons, lasted more than 3 months. And the other belt, which also included the protons, lasted much longer than the electron belt because it was in a more stable region and therefore less prone to the sorts of physical processes which can knock particles out of orbit. As to how long such belts stick around, well, that depends on solar storms. Large storms can provide the energy to knock particles in these belts out of their orbits and send them spiralling either off into space or down towards the Earth. One such storm at the end of June significantly decreased the size of the new electron belt, and another in August nearly totally erased the remainder of that electron belt, though a small population of high-energy electrons endured. NASA's Colorado Inner Radiation Belt Experiment spacecraft is a CubeSat about the size of a shoebox, which circled the planet's magnetic poles in low Earth orbit between April 2023 and October 2024. It carried an instrument called the Relativistic Electron-Proton Telescope Integrated Little Experiment 2, or REPTILE-2 for short. It's a miniaturized and upgraded version of an instrument that first flew aboard NASA's Van Allen probes, which made the first discovery of temporary electron belts back in 2013. After a year in space, the CubeSat experienced an anomaly and unexpectedly went silent on April 5, 2024. Now, the study's authors were disappointed to miss the solar storm in May, but they were able to rely on other spacecraft to provide some preliminary data on the electron belt. Luckily, on June the 15th, the spacecraft suddenly sprang back into life and resumed taking measurements. The data provided high-resolution information that simply couldn't be gleaned by any other instrument, and it allowed scientists to better understand the total magnitude of these new belts. But having the CubeSat in orbit to measure the effect of the solar storm has been somewhat bittersweet. While it provided the opportunity to measure the effects of a large event, the storm also increased atmospheric drag on the CubeSat, causing increased orbital decay and resulting in the CubeSat deorbiting in October 2024. This is SpaceTime. Still to come, could an alien ocean hide signs of alien life? And the largest black hole radio jet ever observed in the early universe. All that and more still to come on SpaceTime. A new study warns that searching for signs of alien life in an alien ocean may be more difficult than previously thought, even if you're able to sample the extraterrestrial waters. A new study focusing on the Saturnian ice moon Enceladus, which ejects water from its subsurface global ocean through cracks in its icy crust, has found that the physics of alien oceans could prevent evidence of deep-sea life ever reaching places where we could detect it. A report in the journal Communications and Earth Environment shows how Enceladus's oceans form distinct layers that dramatically slow the movement of material from the ocean floor to the surface. Chemical traces, microbes and organic material, telltale signatures of life that scientists look for, could break down or transform as they travel through the ocean's distinct layers. And so these biological signatures may become unrecognizable by the time they reach the surface where a spacecraft can sample them, even if life is thriving in the deep ocean below. The study's lead author, Flynn Ames from the University of Reading, says it's a bit like trying to detect life at the depths of Earth's oceans by only sampling water at the surface. And that's the challenge scientists face with Enceladus, except they're also dealing with an ocean whose physics aren't fully understood. Ames says previous studies suggest that an Enceladian ocean should behave like oil and water in a jar, with distinct layers that resist vertical mixing. And these natural barriers could trap particles and the chemical traces of life in the depths below for hundreds to hundreds of thousands of years. Now, previously it was thought that these things could make their way efficiently and quickly to the ocean's surface within just a few months. The new study has important implications for the search for life in our solar system and beyond. As scientists discover more and more ice-covered ocean worlds orbiting the outer planets and even eventually around distant stars, similar ocean dynamics could confine evidence of ocean life and its building blocks exclusively to deeper waters, therefore making them undetectable from the surface. Even on worlds like Enceladus, where ocean material is conveniently spread into space for sampling, the long journey from deep ocean to the surface could erase crucial evidence. This report on the oceans of Enceladus from NASA TV.
In February 2005, we had our first close flyby of Enceladus, and the magnetometer signal saw something unusual.
What a magnetometer does is it measures the magnetic field in the vicinity of the instrument. We had a look at the wiggles, and they looked strange. The magnetic field of Saturn is moving towards it, and it couldn't penetrate down onto the surface, which was pointing to an atmospheric signature of some kind.
Here it looked like it had a tiny atmosphere. In March, we came even closer, looking for that same strange signal.
What it showed was that the signature, the atmospheric signature we were seeing, was focused at the South Pole. It was almost like there was a cometary plume of water vapor coming off from the South Pole.
People were saying, it's gotta be jets, it's gotta be jets. And the imaging team was saying, no, we don't want to say that, until we're sure. And so we went closer. We came within 175 kilometers of Enceladus.
Then we got the data back, and it was spectacular.
And then we found the evidence. Geysers coming out of the South Pole with water vapor and water ice particles. They were active geysers at the South Pole of Enceladus.
Because we were so close, all of the other instruments were able to take really good data. And we put together all of this data. We saw the cracks, the tiger stripes at the South Pole. We saw heat leaking out from these tiger stripes. On subsequent flybys, we found organic material, dust, water vapor coming out of the plume.
The Cassini discoveries in the first 3 flybys were so amazing. We changed our focus and added 20 more flybys of Enceladus, including 7 through the icy jets. The surprising magnetometer reading led us to the liquid water ocean underneath Enceladus' icy crust. After over a decade of research with Cassini, we now know there's a potential for the ocean on Enceladus to support life. And that has altered the way we think about where life might be found in our own solar system and in the worlds beyond.
And in that report from NASA TV, we heard from Cassini project scientist Linda Spilker and Cassini magnetometer principal investigator Michelle Doherty. This is Space Time. Still to come, the largest black hole radio jet ever seen in the early universe. And later in the science report, artificial intelligence may have just crossed a crucial red line, demonstrating how it can survive by cloning itself. Does it mean we've reached singularity? All that and more still to come on Space Time. Astronomers have discovered the largest radio jet emanating from a black hole ever detected in the early universe. This monster jet spans at least 200,000 light years and was formed when the universe was less than 10% of its current age. From decades of astronomical observations, astronomers know that most galaxies contain supermassive black holes at their centers. As matter falls into these monsters, it first forms an accretion disk around the black hole, where material is crushed and ripped apart. Now, most of this will eventually pass beyond a point of no return called the event horizon, beyond which it falls forever into the black hole singularity. But some of this matter and energy is swept up in powerful magnetic fields before it reaches the event horizon. It's then flung out into space, perpendicular to the black hole's accretion disk, forming massive superluminal jets called quasars, objects so bright they can be seen across on the other side of the universe. And quasars can be seen right across the electromagnetic spectrum, with some of the most distant being seen in X-rays. These jets can also be detected with radio telescopes, and locally these radio jets are not uncommon, with a small fraction being found in nearby galaxies. But they've remained elusive in the distant early universe until now. Using a combination of telescopes, astronomers have discovered a distant two-lobed radio jet that spans an astonishing 200,000 light-years at least. That's twice the size of our own Milky Way galaxy. In fact, this is the largest radio jet ever found in the early universe. It was first identified using the International Low Frequency Array LOFAR, a network of radio telescopes acting as an interferometer spread across Europe. Follow-up observations in the near-infrared using the Gemini near-infrared spectrograph and in the optical with the Hobby-Elby telescope were then obtained in order to paint a more complete picture of the radio jet and the quasar which produced it. The discovery, reported in the astrophysical journal Letters, is crucial to getting more insight into the timing and mechanisms behind the formation of the first large-scale jets in our universe. The study's lead author Anik Guldemans from the National Science Foundation says the researchers were looking for quasars with strong radio jets in the early universe in order to help scientists better understand when the first jets were formed and how they would have impacted the evolution of galaxies. Determining the properties of the quasar, such as its mass and the rate at which it's consuming matter, is necessary for understanding its formation and history. To measure these parameters, the authors looked for a specific wavelength of light emitted by quasars known as the magnesium broad emission line. Now, normally this signal would appear at ultraviolet wavelengths. However, owing to the expansion of the universe through space-time, the light of the quasar is stretched to longer and longer wavelengths, and so the magnesium signal from a quasar at this distance arrives at Earth in the near-infrared wavelength range, where it can be detected with the Gemini near-infrared spectrograph. The quasar, named J1601 plus 3102, formed when the universe was less than 1.2 billion years old, just 9% of its current age. While quasars can have masses billions of times greater than that of our Sun, this is a small one, weighing just 450 million solar masses. The double-sided jets appear asymmetrical in both brightness and the distance they stretch from the quasar. That suggests an extreme environment may be affecting them. Guldemans says the quasars powering these massive radio jets don't have an extreme black hole mass compared to other quasars. This seems to indicate that you don't necessarily need an exceptionally massive black hole, or accretion rate for that matter, to generate such powerful jets in the early universe. The previous dearth of large radio jets in the early universe had been attributed to noise from the cosmic microwave background radiation, the ever-present fog of microwave radiation left over from the Big Bang 13.8 billion years ago. This persistent background radiation would normally diminish radio light from such distant objects. It's only because this object's so extreme that Guildermans and colleagues were able to observe it. Now, scientists still have a multitude of questions about how such radio-bright quasars like this one differ from other quasars. It remains unclear exactly what circumstances are needed to create such powerful radio jets, or for that matter, when the first radio jets in the universe were formed. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study warns that patients taking semaglutide, that's the active ingredient in Ozempic and Wegovy, may be at a higher risk of developing an eye condition that can cause blindness. A report in the Journal of the American Medical Association has found a link between semaglutide and non-arteritic anterior ischemic optical neuropathy, which is a blockage of blood flow to the optic nerve resulting in sudden blindness. This is the first study to report an association between semaglutide and blindness. The American Academy of Ophthalmology says if patients are already taking semaglutide and have not experienced any symptoms, they should continue to do so as instructed and discuss any questions or concerns with their primary healthcare giver. Ozempic and Wegovy are used primarily to treat diabetes, but they've become popular for their secondary use as a weight control method. A report on the Pre-Press Physics website archive.org claims artificial intelligence has now crossed a critical red line, demonstrating how two popular large language models can clone themselves. The successful self-replication of artificial intelligence without any human assistance is the essential step for AIs to outsmart humans, making it an early signal for rogue AI. Scientists wanted to determine whether self-replicating AIs could multiply beyond control. Over some 10 trials, 2 AI models created separate and functioning replicas of themselves in 50 and 90% of cases respectively. That suggests that AIs already have the capacity to go rogue, develop self-awareness and autonomy. In other words, it means AIs have achieved singularity, self-awareness being one of the key signs of a unique and separate life form. For the tests, the authors used Meta's Llama 3170B Instruct model and Alibaba's QN 2.5-72B Instruct model, both of which are already widely used by AI developers. The studies explored shutdown avoidance and chain replication, seeing if the AI was able to detect that it was about to be shut down and was then able to replicate itself before being terminated. Meanwhile, a second study instructed the AI to clone itself and then program its replica to do the same, setting up a cycle which could continue indefinitely. Researchers found the artificial intelligence would first explore its environment in order to understand its composition and running mechanism. It then would develop a self-replication plan, resolving any issues without any human help. The authors were also concerned about a number of unexpected behaviours when the AI was trying to overcome obstacles like missing files or software conflicts. In these scenarios, the AI often killed other conflicting processes, rebooted the system to fix hardware errors, or automatically scanned the system to look for information that would help it resolve a problem. The findings show that current large language AI systems already exhibit an ability to self-replicate and can use this ability to enhance their own survivability. Meanwhile, researchers have also developed a new AI algorithm called talk clustering that can significantly improve how AI systems independently learn and uncover patterns in data without any human guidance. Talk clustering can effectively and autonomously analyze vast amounts of data in fields such as biology, chemistry, astronomy, physiology, finance and medicine, revealing new insights such as detecting disease patterns, uncovering fraud, or understanding behaviour. You can read the full report on this truly autonomous AI in the journal IE Transactions and Pattern Analysis and Machine Intelligence. Samsung have now released their new AI-equipped Galaxy 25 in Australia, bringing Star Trek's next generation a step closer to reality. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Ultimately, this is the phone that is billed as your first AI companion, where you have this element of agentic AI, where you can ask your phone by voice to do things for you across a range of different apps.
So this is sort of like Star Trek, where Jean-Luc Picard says, computer, then he asks a question.
Yes, that's right. And the computer then is able to do a series of tasks. I mean, at the moment, when you talk to Siri or Google Assistant or Alexa, it can answer questions, it can set calendar appointments, it can ring somebody, it can take a note. But if you were to ask it to look at a certain YouTube video, extract all the main points out of it and give you a summary and put that into your notes, well, only Samsung's phone can currently do that. You can do it manually. You can copy and paste the transcript of a YouTube video. You can download the YouTube video with one of the many programs that can do that. Then you can get another program to turn that voice into text and then give you a transcript or a summary. So it's possible to do all of those things manually, but to have it happen for you on an automated basis is very cool. I mean, you're giving a command and the AI is working across multiple apps to deliver you a result. And one of the things that's built in to this S25 series is Gemini. That's Google's version of ChatGPT. And so when you're speaking to your phone, you are speaking to it in a human-like manner and is responding to you in a human-like manner. Now, anybody can download Gemini onto their existing Android phone. You can even download it to your iPhone. But on the Samsung S25 range, it is then able to work with a select number of Samsung apps like Calendar and Notes, and then also with WhatsApp and Spotify. And we're going to see many more apps be compatible with this ability to interact with it by voice, get it to do something for you, process some information, dump the results somewhere else, and it's all happened just by asking.
Look, I can't let you go without asking you about the news that AI can now self-replicate. That's got to be frightening.
Well, I mean, this is something that, I don't know, it defines what life is. I mean, to be able to replicate is something that all life forms would want. And it's interesting that with AI, when they've asked AI in these safety scenarios to hide itself, to keep alive at all costs in this enclosed environment, the AI has pretended to, restore itself to an earlier version. It's said that it is an earlier version when it's not. It's copied itself to different areas of a computing system to hide itself. It's like the old Asimov story where somebody told one of the robots they were working on to get lost, and the robot then did. And it was very difficult to find where this robot was. And of course, Asimov's protagonist had different ways of figuring out which was the rogue robot that was too closely following the instructions. But given life replicates itself on a regular basis, it's just no surprise that an AI has figured out how to do it too.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.